Okay, let's dive into this. Have you ever actually stopped to think about the invisible string connecting your smart devices directly to the massive, sprawling global power grid? It's this incredibly fascinating and entirely physical connection that most of us never even think about. But right now, it is rapidly becoming one of the absolute most critical challenges of our modern age.
I mean, think about your daily routine for a second. What if every single time you generated a quick AI video or typed a fun prompt into ChatGPT or just asked an AI assistant to write a quick email, you are secretly helping to drain the world's power grid? I know, it sounds totally harmless when you're just tapping a glowing screen in the palm of your hand, right? But the reality happening behind that screen is vastly different, and the consequences are very, very real. A series of explosive reports, including a major study by Bloomberg NEF, reveals that global data center power capacity is expanding at a rate that is just completely overwhelming electrical grids. It's a fast-moving energy story connecting Silicon Valley's AI boom straight to your living room power socket. Shocking new data shows that data centers running AI are projected to consume 4 times more electricity by 2035 than they do today. Let that really sink in. They are on track to suck up a staggering 1/5, 20%, of all the electricity generated in the United States alone. To put that into perspective, imagine taking the power used by every single home, factory, hospital, and school in 5 massive states and handing all of it over to computer servers. There is an invisible energy crisis brewing quietly in the background of our digital lives.
And we are actually already feeling a tangible financial impact from this. In some key regions, wholesale power prices have already shot up by a jaw-dropping 76% in just the past year, entirely because of this sudden, overwhelming demand. When demand spikes like that without warning, the whole system strains just to keep the lights on for regular folks. This threatens to hit your personal utility bill and hit it hard. So, how exactly did we get here? In this explainer, we're going to map out the whole journey, from the reality of how these data centers actually work to the power grid bottleneck, who pays the bill, the impact on your future, and our final takeaway.
All right, let's start with Section 1, the AI energy crisis, an invisible threat.
Moving to Section 2, let's establish a baseline for how AI data centers work. To really understand this crisis, we have to ground ourselves in the physical reality of the internet. Because every single time you visit a website or stream a video, that data isn't just floating invisibly in the clouds. It is physically stored and processed inside a data center. Picture a massive football field-sized warehouse filled with thousands of high-performance computers called servers. Think of a server like the engine of a very powerful computer, just without the screen or keyboard, designed solely to crunch numbers and route traffic. And they're running non-stop 24/7. Now, historically, traditional data centers were pretty energy efficient. A standard internet search or sending an email takes just a tiny fraction of a watt-hour. But generative AI, well, that has completely shattered the old balance. This analogy brilliantly illustrates the difference. Imagine a traditional data center is like a street filled with standard, fuel-efficient hybrid cars. They drive around smoothly, sip a modest amount of fuel, and park neatly without stressing the local gas stations. Now, imagine that overnight, every single one of those hybrid cars is replaced by a massive, high-powered rocket ship. To get off the ground, a rocket doesn't just sip fuel, it ignites thousands of gallons per second. Generative artificial intelligence is that rocket ship. It operates on a completely different scale of consumption. Training a massive AI model requires running tens of thousands of specialized, hyper-expensive microchips continuously at maximum capacity for months on end. And even after it's trained, every single time you ask an AI to generate a complex line of code or a high-res image, the computer has to run incredibly complex mathematical calculations across billions of parameters. So, the crucial point is this cause and effect loop. These massive calculations draw huge surges of electrical current. That current generates intense heat, and that heat requires another massive wave of electricity just to run industrial cooling fans and massive liquid chillers to stop the chips from literally melting down. Think industrial-sized air conditioners working overtime around the clock just to keep the computers from catching fire. It's a massive double whammy of energy consumption. Which leads us right into Section 3, the power grid bottleneck, where supply meets insatiable demand. Now, what's really interesting about this slide is the severe construction mismatch, because this is the absolute core of what's happening right now. The numbers from global energy researchers are just staggering. By the early 2030s, the new electricity demand added solely by data centers globally could equal the entire annual electricity consumption of a massive nation like India. But here is the root cause of the bottleneck. A tech company can spin up a new AI software feature in a few months, and they can build a massive data center warehouse in under 2 years. But look at the grid infrastructure timeline. Building a new high-voltage power plant, laying miles of thick transmission lines, or securing regulatory permits to connect to the grid, that takes anywhere from 7 to 10 years. Because tech giants are building these AI factories at breakneck speed, they're plugging them straight into regional power grids that are already old, fragile, and heavily strained. They are essentially trying to blast a river of electricity through a garden hose.
And the consequences are already spilling into the real world. Take a look at the PJM interconnection. This is a massive, complex regional grid that acts like the electrical nerve center for 13 northern and eastern U.S. states plus D.C. It keeps the lights on for over 65 million people. But in these major data center hubs, AI operations are on track to consume over 34% of the grid's total available electricity. Over a third of the grid just swallowed up by data centers. That leaves everyone else, hospitals, schools, you and me, competing for whatever is left.
The situation is similarly intense down in Texas, where the local grid operator is having to dedicate over 22% of its entire generating capacity solely to data centers. Now, the Texas grid is already famous for being pushed to its limits during extreme summer heat or winter freezes. Adding massive power-hungry AI facilities into that mix creates a highly precarious balancing act. When you push fragile systems to the brink like this and demand completely outstrips supply, something has to give.
Which brings us to Section 4. Who pays the bill? The high-stakes political showdown.
We really have to pull the curtain back on this political showdown happening right now, because wholesale grid spikes threaten to become residential retail hikes. Let's walk through the exact step-by-step chain reaction. Step 1. Because demand is so high, wholesale capacity prices in some regional markets recently hit their maximum regulatory caps. Remember that 76% spike we talked about earlier? Step 2. Traditional electric utility companies routinely pass those higher costs directly onto the public by filing for retail rate hikes with state utility commissions. And step 3, regular families who have absolutely nothing to do with running AI data centers suddenly find their monthly home electric bills climbing higher and higher just to pay for the massive power lines built for big tech.
To try and stop this, a major political movement emerged, and the White House recently backed a proposed solution called the Ratepayer Protection Pledge. This framework has been signed by nearly 200 entities, bringing together big tech giants like Amazon, Google, Meta, Microsoft, and OpenAI, alongside massive utility companies. The core commitments are pretty clear. Tech companies promise to pay for the dedicated power infrastructure their data centers require, and crucially, they promise to pay for that contracted power whether they actually use the electricity or not. Why is that so important? Well, it's intended to prevent a situation where a utility builds an expensive, massive power line specifically for a data center, only for the tech company to change their mind or leave it idle, sticking local families with a long-term bill for something they never even needed.
But energy policy experts have dropped a major reality check here. The pledge itself is entirely voluntary. There are no formal federal penalties, no binding laws, and zero legal enforcement mechanisms keeping it in place. Because retail electricity rates are legally set by individual state public utility commissions, not the federal government, those state-level commissions are the real gatekeepers of your wallet. The ultimate test is going to come over the next few months as utility companies file their formal rate cases at the state level. It will be completely up to local regulators to decide if they'll force tech companies to keep their word or if regular citizens will bear the cost. So let's look at Section 5, the impact on your future, and how this is changing the fabric of tech. What does this all actually mean for you? We need to connect this macro-level gigawatt crisis back to your daily life. First, obviously, is the threat of a continuous rise in your household utility rates if those state regulators fail to strictly ring-fence the costs. But beyond your wallet, look at the radical shift happening in how artificial intelligence itself is designed. Because power grids are hitting absolute physical walls, tech companies can no longer just rely on making data centers bigger. This is forcing a massive shift from giant grid-level computing down to extreme chip-level efficiency. AI researchers are frantically building smaller, hyper-efficient AI models designed to run directly on your personal laptop or smartphone using just a fraction of a watt. Instead of sending your prompt 1,000 miles away to a warehouse, your phone's internal chip will process the request right there in your hand. This bottleneck is literally accelerating a future where your personal devices become exponentially smarter and completely self-reliant. And finally, on a broader scale, this crisis is driving an urgent, multi-billion-dollar demand to build cleaner, faster, and more resilient energy infrastructure, sparking serious investments in advanced nuclear reactors and modern renewables. Which brings us to Section 6, the final takeaway. The digital world is physical. For years, we kind of treated the internet like an invisible, weightless magic trick with zero physical consequences. But the digital world is undeniably physical. The rapid quadrupling of data center power demand proves one crucial thing. The growth of artificial intelligence is no longer just a software revolution. It is a massive physical energy challenge. Every single byte of digital intelligence is deeply anchored in the physical world of steel, copper, water, and power plants. The sheer speed of AI growth is literally forcing a complete redesign of our global power grids and our computer chip architectures. It's a really striking reminder that the digital future runs on real-world power, which leaves us with this final, incredibly important question to ponder. Now that you see just how much energy artificial intelligence actually consumes, do you think tech companies should be legally forced to build their own private power plants before running these massive AI data centers, or should state grids accommodate them to speed up technological innovation? It's a huge debate, and it's one that is absolutely going to shape the physical reality of our digital future. Thank you so much for joining me to figure this all out. Keep learning, and I'll catch you in the next explainer.